Hello everyone. Can you guys see my screen? Okay. Welcome to today's KubeEdge SIG AI meeting. I'm the host, Shijin Hu. Uh, First, let me introduce a little bit about the KubeEdge SIG AI. KubeEdge SIG AI focuses on AI and edge cloud synergy with two main projects, Sedna and Yanos. Sedna enables edge cloud collaborative AI with support for joint inference and federated learning across major AI frameworks. Yanos provides benchmarking tools and test cases for evaluating and optimizing distributed AI solutions. Okay, let's move on to today's agenda. First, in the international session, we will have two projects about the Linux Foundation Mentorship Project. And first, the first project is from Abstract and Zimu Zheng, the comprehensive example restoration for Yanos. So now, Abhishek, you could share your screen now.
Yeah, sure. Yeah, is my screen visible?
Yes, we can see your screen.
Yeah, so I have created this proposal for a comprehensive example restoration. And I have given this background there are 25 plus examples that are broken and like these are need to be restored. And this is all what we exactly know. I once served as a KubeEdge SIG AI distributed benchmark toolkit. And throughout this proposal, I have tackled like how I will be solving and restoring all those 25 plus examples. Like uh, these are the goals that I am targeting. Like my goals are like for developers and end users of distributed synergy AI solutions, facilitating efficient development. My first goal is facilitating efficient development for developers by ensuring reliable test case, including dataset validation and corresponding tools. And other one is revealing best practices while restoring these examples. And this is what my proposal that I have created for this LFX mentorship. My scope of this restoration includes providing end-to-end example reliability for all the examples. Like I am including tools that can validate the test environments, including dependency compatibility, checking license, compliance scanning. These tools will be automated. And apart from this, I have also tried to write Python scripts that will automate the monitoring of example health, including runtime validation, performance profiling, and automated failure detection. And also one more tool to maintain documentation automatically so that there is excuse me, Ronak, I think your mic is on. Yeah, it's okay now. I am also integrating tools to maintain documentation. Like I am automating the script that will automatically maintain the documentation also. And apart from this, like it's in cooperation with the KubeEdge community to establish comprehensive example maintenance best practices. Apart from this, these are the targeting users like developers, contributors, and end users. And this is like what is not the scope of this restoration. Like we are not creating another architecture or another platform for this thing. And these are the design details. This is how the user flow work, and it is same as the previous one that is currently working. we are validating the test cases. We are enhancing the IVAN's preparation. We are also focusing on reliable algorithm development. We are automating IVAN's configuration and monitoring IVAN's execution. And apart from this, like I have also given the architecture and modules of this. And in the architecture, I am introducing one extra framework. I am introducing the dependency validator that will actually validate package compatibility across different Python versions. I am also trying to include license scanner that will ensure compliance with the open source licenses. Apart from this, I am also trying to introduce path validators that will verify datasets and configuration file accessibility in the test environment manager. And in test case controller, I am also introducing runtime validator that will ensure pre-execution compatibility checking. And apart from this, I am introducing performance monitor that will ensure resource usage and execution time tracking. And these two things, generation assistant and simulation controller, are unchanged as these are in current KubeEdge architecture. And in story manager, I am adding documentation synchronizer that will automatically auto updates the tutorial based on the code changes that we have done in the examples. And there is one new enhancement layer that has components like CI/CD pipeline manager, auto example health monitor, and auto documentation generator. These will automate the things that help in restoring the examples, and it is a process of both automating and manual working both. Like we have to fix the examples manually, but the rest of the things can be automated. And this is the architecture of what I will be doing. Uh, like I am introducing this new thing, CI/CD pipeline manager, example health monitor that will monitor the health of the examples and automating the documentation. And this is the part where I am making the changes, like adding dependency validator, license scanner, and path validator. And all other things are same as in the previous architecture of the IVANS. And apart from this, these are basically the definitions of benchmarking job, etc. And this is the hierarchy. And these are like the details of enhanced modules that I have recently explained. And this is the file structure that was asked in the previous meeting that I has to make. And this is exactly what I will be doing inside my project in the upcoming months. And I have also given the my weekly progress on what things I will be working. Like in week 1 to 3, I will be tackling the critical infrastructure restoration, and here I am fixing the file incompatibility across all algorithm implementations and resolving NumPy and TensorFlow versions, etc. And similarly, in 4 to 6, I will be doing example category restoration and solving the restoring these examples like PCB, AIO, and incremental learning in that, and also the lifelong learning examples that are 5 in number. And this is the week 7 to 9, where I will be working on CI/CD pipeline implementation. And at last, I will be working on the phase 4 of my learning. That is week 10 to 12. That is documentation and community integration, where I will be enhancing the documentation of the IVAN's project and the examples that on which I will be working. This is all from my side, and I will be highly grateful for your reviews on this proposal and what changes I need to made on this.
Great. Oh. Hi, Abhishek. Very impressive proposal. Thank you for the hard work. I have
Thank you, sir.
several. Yeah, I have several questions. But first, so we are adding a scheme to check whether the examples are running normally, right? So this proposal is not about fixing one or two example. It aims much higher. It aims to automatically find the errors that existing in current examples and try to provide I don't know a list or some results that some error logs that the current example could exist. That the main goal looks like this.
Yeah, I didn't got the question. Can you please repeat?
Yeah, I'm questioning about the goals. What we are going to achieve is not like to fix an example or two. We are aiming a higher goal. It looks like to create a scheme that it is possible to check the existing examples or the submitted examples to ensure that it could run properly and automatically generate some logs or documents that help us to know what is happening in a submitting example. Is that right?
Yeah, I got the question. Actually, I am fixing the examples manually, and apart from this, on a higher level, I am also trying to automate these things so that these problems not occur in future also. This is like my goal for this. That's why I am fixing the examples manually and automating the other things so that these don't cause error in future also.
Great. I think that is very important and critical part for our KubeEdge Janus. Currently, we have 25 or more examples are building, and they, we need to check their health continuously. So this would be important. What we suggest to do is to add extra components for the Janus file. So not only we need to modify the origin, for example, text environment manager, and also we need to add a new layer, right?
Yeah.
So so it will affect the KubeEdge Janus core code by, for example, we have currently have 3 modules, and now we have 4. We need a extra layer. But how we maintain the extra layer? As we know, the other 3 components are working in development phase, right? So when a developer try to test some algorithms, it opens KubeEdge Janus and run it to see where how to benchmark an algorithm and how an algorithm performs. It looks like this. But how do we use the extra layer that we add? I'm sorry. What would be the name of the layer again?
Enhancement layer. That will contain CI/CD pipeline manager, example health monitor, and auto documentation generator.
Okay. Can you roll down a little bit? Let us take a look at the new component. Could you show us the component description of the new component so we can have some discussion on it?
I didn't got the question, what you want to ask. Can you please repeat that?
I'm requesting to could you help us to roll back the page a little bit so that we can see the new component that you propose to add.
Yeah, this thing, right?
Yeah, the enhancement layer, right?
Yeah.
My question is that basically the enhancement layer works in a entirely different way that for the Janus project. The
Yeah.
Janus project is basically in a development mode, right? So it is for developers, but in fact the enhancement layer it is for maintainers, right? It is for
Yeah.
Then it seems it is not entirely in the scope of Janus. That is my most critical concern about our what we are going to do. So we are suggesting to add the enhancement layer into the core code of KubeEdge Janus, right?
Yeah. Yes. Yeah. Somewhat like this.
Then it
If it's like
the
if
question
you
raised.
think it will work and it is fine, then I think
I think that it is not a very good design if we add just add the code the enhancement layer, just add the enhancement layer into the core code. I think it is not quite proper because currently as discussed the test environment manager, the test case controller, and story manager is basically for developers, but the enhancement layer it is for maintainers. So I wonder whether we should add, mix those codes together because the user is entirely different, right? So maybe we should have two kind of interface for those they are for those developer they just want to use KubeEdge Janus. They use the origin interface, and for maintainers for example we have more directories have other directory than the original core codes. We have another directory maybe called maintaining or something like that. That on that directory, in that directory we put some codes about those enhancement layer components that is for the sake of the maintenance. For example, you can open up the code space of KubeEdge Janus. We can see that we have some directories like the core, the documents, the for example user interface or something like that. So I don't think it is proper to just add the enhancement layer into the documents. For example, the CI/CD algorithm, maybe we can put it somewhere out of the core code of KubeEdge Janus. What do you think about that?
Yeah, I think if you suggest to keep it out of the core code, then I will do that. And I would also ask should I implement this thing or should I go for something else? Thing like what are your suggestions for this?
Okay, so can you show me the directory of what you are going to propose in the community? I I saw some directory documents in the proposal, right? You can show us again and we can have some discussion on it.
So what I need to show?
Yeah, you can roll down the page. I saw
Okay.
some directories and files we want to add. Yes. The file structure enhancement. Load down a little bit. Yeah, this one. So what we are going to add, so this one it is the current status of the Janus, right?
Yeah.
Okay. So do you have any structure like this, but showing what this project will going to add into KubeEdge Janus?
Not exactly right now, but I will look into it. Like
Yeah, maybe you can give me the screen and maybe we can discuss right away based
like
on
should I
the
stop?
Janus. Yeah.
Should I stop my sharing screen now?
Yes. Let me share the screen. Thank you. So everybody see my screen, right?
Yeah, it's visible.
So my first idea is that maybe we can add another directory here, maybe called maintenance. That one is to put those code that are necessary for us to build the enhancement layer. Yep. For example, the CI/CD things, the hosting, something like that. But it is totally different from the core part. What the core part, what we put into the core part is basically for developers. So for those developers, they launch KubeEdge Janus by using codes in the core part. For those contributors to KubeEdge Janus, they need to refer to our documents. And for the users of our KubeEdge Janus, they open up the examples, and then for maintainers, they open up the maintenance directory, something like that. So in this way, we do add a new component in KubeEdge Janus, but it is for another sake. That's my first suggestion. I think they would make the user flow more clean. So then let's coming back to your proposal. Have you submitted to our
Yes,
community?
yes, I have submitted. Yeah, I have created a PR.
Great. Let me maybe just open up it. This one, right?
Yeah.
Okay. So I think that we should revise the goal a little bit. So it is not for developers and end users. I think that the most critical part of this project is for maintainers of the KubeEdge Janus, right? Maybe you should write the goals in the view of maintenance developers on maintenance that's maintenance. And then maybe I think there are two kind of users. For the first one will be maintainers that they are trying to monitor the health of this KubeEdge Janus open source project, and also the second type of user for this proposal will this project and will be contributors. When a contributor they try to contribute a new example or new algorithm to KubeEdge Janus, then we automatically run the restoration functions, right? I think you could take a look at those two new users in KubeEdge Janus. Then try to do validate the test environment, monitor health, example health. Maintain documents. And check dependencies. We have testing pipeline. With multiple version Python support. Documentation. I'm a little bit confused by this one. How would this project help to help for the performance benchmarking and regression prevention mechanisms? Could you introduce a little bit about this one for us?
I am targeting to enhance digit jumpers or restore digit jumpers that can performance benchmarking also. But I have no idea I will find out how I will be doing this. But I think I can do this also by somehow.
So maybe you can take a look at this one and see whether that is really for this project. Okay, and then community contribution guidelines or validation standard. I think that this one will be some documentation, right?
Yeah.
Okay, that's fine. So I think the targeted user will be our contributors and our maintainers for this project. And as for the detailed design, then we can see the user flow. So this one is typically for our developers. Right? It's a developer user flow. But
Yeah.
as we discussed, in fact, we are targeting for another two users. The first one would be maintainers, and our reviewers for this for KubeEdge Janus. And then another kind of user will be our contributors. So you may need to revise the user flow of both contributors and maintainers. For example,
it will be for maintainers, developers, and contributors.
Yeah. I think that when we're talking about Janus developers, it means that it means those algorithm developers that they want to use Janus as a benchmarking tool so that they can develop algorithms more effectively, right? So to differentiate those developers and those contributors to the Janus project itself. So I have two names. The first one would be developer. That means those want to develop an algorithm using Janus as benchmarking tool, but they will not adjust any core code of KubeEdge YANUS. Another type of user is as I said, contributors. They are trying to add some codes to our open source community, and they could adjust the core code of our repository. So that's two kind of different type of user in our different types of role in our open source community. So for my point of view, I think the user for this restoration project is two kind of user. The first one will be contributors, because they want to add some codes in KubeEdge YANUS that could lead to the failure of some of our examples. So we need to check their codes, and in that case, they need to run for example, the enhancement layer. The second one would be some maintainers or reviewers in our community. They want to check the health of the overall open source project and see whether it is going well. So basically, there are two types of users for this project. I don't know whether I have make it clear. So it is entirely different user against the original user of KubeEdge YANUS. So at the case, we need to update our user flow. We need to stand in the role of, for example, maintainers or contributors to see how they use this project. So, for example, for contributors, they want to make contributions to the KubeEdge YANUS, so they submit some pull requests to the project, and then they run the maintenance tool. Then they check whether, for example, we have some CI/CD process, and they take a look at it and see whether there is some problem happen. If so, they fix the problem. If not, maybe the contribution are ready for merging into the open source community. As for maintainers, they will run our tools for example, every several months, and then they take a look at the overall project process to see whether all the examples are doing good. So I think typically they have two different user flows, and which is entirely different from the previous users. So I think we need Abhishek to try to bring this up and design the user flow for contributors and maintainers to see how they use your tool. So I don't know whether I have made it clear so far. Hello, Abhishek. Do you have any questions so far? I don't know whether I have made it clear.
Yeah, it is clear now, and I will make all these changes that are suggested by you in my proposal.
Wait, okay. And then so far so good. So we continue. And I think these functions are these functions are all necessary. But my question is basically whether we need, maybe we need these components, but maybe it should be put into the enhancement layer instead of test environment manager.
Yeah, I will do that. Like keep these scripts in the enhancement layer only, not in the test environment manager and test case controller and story manager.
Yes. So I think those algorithm developer, they just use the origin KubeEdge AI tool is fine. But for those contributors and maintainers, they use your enhancement tool. And maybe we also need to change the name. It quite it's not very super clear about what do us mean by enhancement. So maybe I prefer maybe some other name like I don't know, maintenance layer or something like that.
Yeah.
Maybe it would make the purpose more clear.
Yeah.
Okay, and then we need a directory discussion to see what we want to add into community. So you can take a look at the document, the modules, and also the file structure. What do you mean by 60% restore?
Like, by automation, I think it will be 60% restore, but I have to do some manual things also to make it completely restored.
Okay, the 60%, do you mean maybe I have eight examples and maybe 4 or 5 examples are working well, so maybe
this is thing also.
Yeah. This one, in fact, it looks like a report, right? I think it is also useful if we can, our tool can create a report of the current keyword Janus. You can take it into your design consideration.
Yeah.
Then finally, we can take a look at the roadmap. We try to fix some algorithm implementations, dependency verification framework. So basically, you start with the work by manually fixing TCP/LI examples, and then build a automatically testing framework based on the examples, and try to restore more examples using this. But I wonder whether it is the workload looks like quite heavy. Yeah, you may try, but I think maybe we do not need to fix all examples in 3 months, especially when we still want to add a automatic tool. Maybe we can manage our outcomes a little bit. My suggestion would be maybe we can focus on one example and make it end-to-end executable, and then we try to develop an automatic tool that try to see how this tool could be used in existing examples, and then maybe we do not need so much functionalities in one project. Maybe maybe we can take a look at, for example, I think the CI/CD pipeline manager would be the most important one. So my suggestion is maybe you can start by, for example, fixing one example and then build a CI/CD pipeline and try to run the CI/CD pipeline based on the existing examples to see whether it can detect some for example, execution errors that could raise in the CI/CD process. And then the next important things would be dependencies, license, paths. That if we have some kind of report like this, it helps us to see how those examples go wrong, right? So, but I think it is a plus, not a necessary one. The most important one would be the CI/CD pipeline, that it try to show whether one example can be end-to-end executable, and if it is necessary, print some logs about how this example failed. I think that is the most important one. So maybe we do not need to do everything in this proposal. Maybe we can have the roadmap more have this roadmap reconsider to have, I think, at least one example is end-to-end fix, and then we try to build a CI/CD pipeline. I think it is already good enough for this project. And then if we have more time for this FFS program, we can add more, for example, health monitoring, some document generators, or those validators into the project. What do you think, Abhishek?
Yeah, okay. Like you want to say like this, that I have to work on one example and try to fix end to end, and then work on CI/CD pipeline manager. Apart from this, if we get time, then we will be working on the automated things that I am proposing.
Yes, exactly.
Okay, so I will make the changes in the proposal accordingly. Like I will be fixing the one example end to end, and also then working on the CI/CD pipeline on a priority basis. And apart from this, I will not work on the automated thing as of now.
Great. Okay. So I think that is all from my side. Any other comments from our other members?
Hello. Can you hear me?
Yeah, you're audible.
Yes, generally agree with the most suggestions. I think the proposal overall it looks fine to me, but I think the workload for this proposal is maybe a little bit too system for just one RFX mentorship project. So maybe you could you could do the high priority issues first, like to fixing maybe one or two examples, and then if you have still have some time, you could to do the automatically fixing the other examples or the other modifications to the core code of Yanos. So that's all my suggestion.
Yeah, sure, sure. I will keep this in mind and do the work that is suggested by you and Jimu on a priority basis.
Okay, that's all. So is that the end of this proposal?
Yeah, can I ask one question?
Okay. Yes, you could ask.
Yeah, I want to ask, can you please suggest me, on which example I should work as of now to fix it end to end? Or should I select it by myself? Or if you can select, it will be a great help for me.
I think it's fine for me for I don't have too much idea on this, so I think it is fine for you to select an example that I think it could be, for example, it could be difficult difficult enough or challenging enough that you can come across as much as errors that you can see in the in, in the execution project, the execution process, and then when you get those errors, you can more aware about what would happen in in the algorithm development, so that when you build the CI/CD process, the exceptions and errors that you can get could be more comprehensive. But basically, I think it is fine for you to. It depends on you. So just some tiny suggestions.
Yeah, from my point, I think the lifelong learning example is most complex examples in our Janos. So maybe you could start with the lifelong learning example.
Okay, for sure. I will look into it, and if I got any problem, then I will ask to you. And explore all the examples by my side, and I will choose one of them and try to fix it end to end.
Yes.
Thank you so much.
Okay. Thank you, Abhishek. Now we'll move on to the next proposal, which is the deformable component assembly of the Industrial Embodied Intelligence Project for Janos by Ronak. So hello, Ronak, you can share your screen.
Hello, everybody. Am I audible to everyone?
Yes, we can hear you.
Okay, so soon I'll be sharing my screen, so let me know if the screen is visible or not.
We can see your screen now.
Okay, so first of all, thanks for the opportunity. And basically, my project, Embodied Intelligence Industrial Assembly, I have decided to add a data set that is regarding deformable component assembly. So basically, this is like a very creative scenario where we or the robots are responsible for fixing the soft components of those which cannot be handled by humans onto a motherboard of a mobile phone, or may let's say a laptop motherboard. It could be anything. So this is a precise component assembly. So I have created the proposal. I have already added the introduction of the complete data set, that how this data set is going to be working with KubeEdge AI framework, and the simulation environment, the benchmarking pipelines, and all the real world constraints in our industries. So basically, the proposal, the goal of my proposal is to create a brand new data set that does not exist, of course, in the market. So my data set is going to involve a lot of components, which those like these components are very precise. They are very difficult to handle, and there will be a big motherboard of let's say a laptop or a smartphone, and there will be a robotic arm which will try to fix each and every component, picking up and trying to detect the position and place it where it's required. The major components, the basically in my multi-industry assembly dataset, I'm going to use a lot of URDFs for creating the components because no public dataset exists that can give me those components which I want in a dataset. There will be use of camera images. Most important thing, there is going to be a force torque sensor data because these components are soft. It requires different sort of force and different ton of force to be picked up and to be used so that they are not broken in the complete inspection. So my goal is going to build a multi-model industrial data set, develop an end-to-end assembly pipeline, integrate multitask AI capabilities, create a conditional detecting framework, compile a list of key related research work, and of course, the comprehensive benchmarking suite that fits in the core module of Canvas. This is a complete design detail for all whatever kind of the related data sets that I am going to use in my data set for the training of my AI robot, AI model. I mentioned them all and all the kind of researches that has happened on the same kind of operation scenario of the industrial benchmarking. I have mentioned it here. After that, what basically my data set do? This is an embodied intelligence robotic arm. The robotic arm leverages a fusion of advanced capabilities, including force detection, delicate haptic control, positioning, data-driven intelligence, and store, compare, and verify each assembly step. So this is all about it. The Yanvis proposal. So basically, my data is not to harm the code of Yanvis. Rather, I try to manipulate the code in such a way so that it fits perfectly into the repository. The final directory structure after I implement the codes of the dataset would something be like this. This is going to be the architecture and the complete data structure. Like I'm going to come back to it. This is just a glimpse if the maintainers would like to take. Now, this is not a single task assembly work. This is a multitask assembly project. So basically, it's going to do a multitasking. Multitasking. Like for example, this is a complete working of how that work is going to happen. Developers create and deploy the application of based on the multitask learning framework. The application runs and launches the full assembly workflow and then includes a series interdependent tasks. Now I'm using the algorithm of YOLO V8 so that the robotic arm detects which component needs to be fixed at which point. After that, the robot executes the force control assembly. So the proper force and torque sensor is required. Basically, the robotic arm needs to know what Newton of force to be put on what component of the motherboard. After that, there are two things that I want to especially add from my side that is related to AI, and I think this will make my data set better. First thing is the visual inspection. See how this happens. Like for example, the motherboard is there on the panel. The robotic arms uses its sense and the sense of touch and vision to properly fix each of the component on the motherboard. And then after, there is going to be a predefined ideal picture of the well-fixed motherboard already in the data of the robotic arm. Now, after fixing the current motherboard, it's going to check from the picture whether the current fixed data set, sorry, the current fixed motherboard looks proper or not. It checks if all the components are fixed at the right position or not, comparing it with the picture that is already in its data. Now, if this thing works, like for example, the current assembled motherboard and the ideal assembled motherboard that's already in the data, if both the pictures matches, then this camera actions it and visual inspection take place. For this, I'm using the CNN based model dataset to check the quality. And if this passes, active. So there comes another case of if else that I'm going to add to it. What is this case? Like how the scenarios work. Uh, the motherboard has two different type of components. Let's say the component A and the component B. If during the fixing of the component, the robotic arm uses a component A in the motherboard, then while the final packaging, there are of course like if we get phones, right? We phones and apart along with the phones we get USB cables with them, the chargers. Okay, we get the USB chargers with them. So if the smartphone, if the motherboard has the component A, then the USB-C is supposed to be fixed with the packaging box. And this is the detection that the robotic arm does. So the robotic arm at the end detects that it's already its data that if it has used component A in the motherboard, then the USB-C cable has to be placed in the box. If it has used the component B, then the USB-B cable has to be in the box. And everything works well, and the final box is done, and the package is completed. So this is a complete industrial working of how a smartphone's motherboard is fixed. The charger is placed along with it, the USB cable is placed along with it, the box is covered, and the product is finally done. So this is the part I'm including. So these are two scenarios. After that, coming to the algorithm, for the algorithm, I'm using PyBullet for the simulation. The complete simulation environment will be based on PyBullet. UV is going to be used for the object detection. Pose CNN is going to be used for the 3D pose estimation, like for comparing those two images of the motherboards, if they are well fixed or not. And then the robotic arm trajectory grasping, the deformable assembly, the visual inspection. For these, I have used different kind of algorithms at different places. So these are all the algorithms, or let's say the targets the robotic arm is going to perform. The component positioning, the robotic arm trajectory, deformable assembly, visual inspection and detected friction, logical decision making, cable type recognition, logical decision making too, and the final packaging. For checking the quality, so because I believe those two parts, that is the if else part of fixing the USB cables, that is a little complex for people to understand. So I have added a detailed section to explain it in the proposal, and that AI driven quality assurance part where the motherboard of the phone or the smartphone, whatever the component is, the motherboard is detected whether everything's fine or not at the end. That part is also tricky, so I've added another section to explain that part. So these are two parts. For the data set, to make the data set better, of course, I'll be creating a new data set that will be from my side. For creating the data set, I'll need the bipolate simulation. I'll be using URDS. I'll be using the assembled phone images and everything. And then I'll be writing the code to generate the data set. I'll generate the complete data set. It's going to be a huge data set, like somewhat 1 lakh files. And after that, I'll download it and upload it in the Kaggle. That's it. We don't want the data sets to be inside the repository to make the repository heavy and unnecessarily confusing. I'm going to use the reassembled data set for the practice test of how the arm uses or how the robot uses its fundamental skills for assembling the components. I'm going to use deep PCB dataset for collecting the images of electronic circuit boards. These are the datasets I'm using. These are the algorithms I'm adding. After that, the data set is going to have a certain structure. This is again, I'll come back to it. It's just a glimpse. After that, the key outcomes of it is to create a multimodal dataset, create an integrated multitask algorithm, a reproducible benchmark suite. So these are the key outcomes. After that, what are the matrices? Of course, we'll be using Yanvis for the final benchmarking and evaluating the matrices. Like we are going to check how the assembly was, like if the accuracy of the assembly was perfect or not. The matrices are going to include the assembly accuracy, defect detection accuracy, time efficiency, shorting accuracy, and the force control consistency. These are all the most important thing, and these are the matrices in this data set gonna have. I have added the roadmap as well. The phase one is going to be the September phase where I'll be creating finalizing the proposal. After the proposal gets launched, I'll be collecting the URDFs, writing the data set, creating the data set. Second thing, the October phase, where I'll be adding the YOLO part of detecting of the object detection part and the quality assurance part, the CNN data set and everything, the framework, this is the October part. The last November part, I'll be uploading the data set in the Kaggle website, implement the if-else condition at the last. The documentation of the README will be done in the October phase. This is the roadmap. Final conclusion that we are going to get a high precision perception, intelligent manipulation, and logical reasoning. So I've added few images also. I've seen the rest of the proposals. I've saw really great images to be added. So for the proposal to look better, this image is of the CNN part, where the robotic arm is detecting whether the assembled motherboard looks with the perfect assembled motherboard or not. So this is the detection. This part is already in its data, and this is the current assembled motherboard. So it detects whether both the pictures and everything matches or not. It uses CNN. So there is a 6D checkup. So every of the component is at the correct position or not. This is the accurate checking. After that, this is the component of a motherboard. The motherboards, like they are very different kind of components, which are very deformable, which are soft, which are precise, like the graphic cards, sound cards, connection sockets, CPU sockets, etc., etc. This is the scenario where the cable is added to the box. So these are the cables. The robotic arm decides whether it's going to be a USB-C type cable or USB-B type cable based on the component it had added in the data set, sorry, in the motherboard during the assembly. This is just a picture showing how the robotic arms works in industries. Of course, maybe if this is not the present, this could be the future. These are the robotic arms. They are fixing the laptops or the smartphones or many different gadgets, motherboards, or any kind of sockets. So this is the working. This is the working and algorithm and the complete workflow that how it's going to be working with YANVIS. So how the inputs are going to be there and how the outputs are going to be uh, produced. Like I can see the YANVIS story manager. It produces the test reports, the leaderboard, and the matrices and everything. So this is the complete working, how the work happens. This is a close-up of each and every component, how it looks like. These are the main components like the CPU sockets, the RAM slots, chipsets, the cooling mounts. These are how the motherboard is fixed like. These are the images of robotic arm. These are the actual robotic arms that are used in the industries. And this is a small scenario, a small glimpse of how the 5 bullet simulation looks like. The fixing, this is of course the initial part. Is a lot of many things are going to be added to this. A single workflow that clearly checks and clearly tells what the working and the multitasking is going to be, how the developers creates it, how the visual inspection take place. If the visual inspection is passed, it goes to the next step of the robotic arm, solve the cable, and the final report generation. So well, this was my project. Now, how I decided to make this data set was one minute. Look at this picture. Now, this project of embodied intelligence, it already has 2 contributions. One contribution was Anshu's project, who was the last LFX mentee, and one contribution is by CGL, whose proposal was recently merged. The primary task, how my project is different from theirs. This is a small comparison to show, because I want the data set to be a little unique. The same type of thing should not be added again and again. I've already narrated each and everything, like how the primary task category, they had perception and locomotion. My work is operation category. The name is deformable component assembly. We are going to work on deformability and force control. The simulation platform is PyBullet. The dataset type is, of course, a new dataset we are going to use. The algorithm is YOLO V8, and there are different datasets like Reassemble, Deep, TVN we are going to use. The main contribution is high precision touch sensitive task. One thing is there that Anil's project and CGL's project had vision in them, but they did not have touch. The sense of touch did not exist in their dataset. My dataset has vision as well as touch. So thank you, everybody. This was my proposal. Now, if I don't know whether this is very good or not, so I'll let the maintainers think about it and comment on it. Thank you.
Thank you so much, Ronald. I think that is a pretty good proposal, and it is quite close for even a final version of the proposal. So it is a comprehensive one. Thank you so much for the presentation. I appreciate it very much. Then from my point, I think it is pretty much what I have on my mind and what I expected to see in a proposal. Thank you again. And then as for some comments, I have first of all, I have some questions to ask. The first one would be why we need a multitask program. To my point of view, it seems like we are working on a manufacturing process, and it needs several phases comes one after another. So it seems to me that we do not need those outcomes produced simultaneously. So I wonder how the multitask work. Do we really need to have multitask outcomes produced at the same time, or we just need to, for example, we do the object detection first, and then we have some other control algorithm afterwards, and we just conduct the algorithm one by one. We may not need to have a traditionally multitask algorithm. It's just multiple single task algorithms. This is my first question.
Okay, so this question, why it becomes multitasking work? Because we want to add and make our data sets little better than the others. And this was my try. That's why it becomes a multitasking work. Otherwise, the single tasking data set was enough uh, to be satisfactory, in the proposal. So why it became multitasking was my extra intelligence that added to it. So if this is not working, the single tasking algorithm works well, then I'm happy with it. If it feels like the USB cable part or the if else decision part is just a confusing thing or is not a necessary requirement, a single tasking work is going to be better than that, then I'm happy with it.
So what we are what we have here is, in fact, we have multiple different industrial tasks to tackle, right? So we have, for example, some USB things, some other components that we need to manufacture it. So you just do some extra work to make it happen, to simultaneously build some build different components and try to assemble it together. And I think that is good. Just to my point of view, I think that could be conducted by multiple models and even multiple robots. For example, for a robot arm, it can only conduct one task at one time, right? So I do not see the very need of to tackle or to have different tasks tackled on the same time. So I think it should be fine if we have a single task one, but it still can have a multi-model one that which means that we can have, as you said, we can have the image data and for example the touch data, something like that. We can have different sensors for one task. I think that one the data set itself is still valuable. But to my point, I think um, I think the single task one should be put in the first priority, and then if we have more time for this program, we can add more tasks for the data set. And I think that is also very welcome for the KubeEdge community and also the cargo community. So my suggestion would be, first, this project seems to me it is a multi-phase single task algorithm. So I don't think we need to start a multitask algorithm right away. That could make the project more complex, and we do not. I don't think we do not need to add extra burdens for this program. So at the very first time, I suggest that we can just start from a single task learning one, and we focus on, for example, benchmarking the I don't know the vision part using YOLO VA, or some other YOLO algorithms. So this is the first suggestion. So that we do not need to add this one using the lifelong learning bench. I think the single task bench is already good enough for us. The main purpose of this project is to create a brand new data set for the industry. So let us focus on the data set itself, and then build a perfect data set by all means. And then as for the algorithm part, I think we just make it simple, and then we can focus on the data set, the building of data set itself. This is the first suggestion. And then if we have more time for this program, we can add more tasks, of course, for add more data sets in the project, and even add more algorithms to the project for benchmarking. I think that is good enough. And as for other things, can you show us the architecture of the proposal, from the proposal?
So this is the architecture.
Oh, this one is the file architecture, right? Let me take a look at it first. So that we are using the single task learning bench instead of lifelong learning one. And then the other things seems fine. Then we do not need the data set directory, because it will be an empty data set in Janus, right? So I think we just leave it in the tutorial, but we do not need to add it in the KubeEdge Janus repository. I also see another file called view dataset. What is that code for? Viewing a local copy of the download dataset. Why we need to view a local copy of?
Well, this is
Yeah.
well, we need to remove. I think we need to remove that file, because that is going to make it mesh. That is going to make it meshy.
Okay. Then of course we need to remove some the caches, the guilty, not ignore, something, things like that. Yeah. We don't need to make it too messy.
So
Okay.
that view dataset file is required for me for generating the dataset, not for the Yanvest repository.
Okay. So yeah, I think that is it is a tool, right? So I think it is not necessary for Janus, so it's fine. Okay, I think we can safely remove it. Okay, and then can you show us the project architecture, the one with test environment manager, test case controller, story managers. I think you have a figure showing the overall project architecture.
Like, do I show the dataset architecture?
Please show us the coding architecture or implementation architecture. And not only the dataset one, the implementation one. The figure with
Okay.
Test case manager, test environment manager, story manager, something like that. Yeah, this one. So what are we benchmarking here? I think we are benchmarking YOLO or CNN algorithms. That is for that is we are benchmarking object detection, right? So is that true, or we are benchmarking the whole end-to-end process?
Actually, this picture shows how the input and output works. The complete working of the Yanvis story manager and the core module. I think that is a missing part in my proposal because I just mentioned that doesn't change the core module, but it doesn't show how the implementation of the core files and the core module works.
Okay, I think maybe we can add an architecture showing what we are going to revise in the in KubeEdge Janus. So first, I think we want to add a new data set, right? Then
Yes.
it is for building a new test environment, so you can mark it maybe in the test environment manager. And then for test case controller, I don't know, maybe we are contributing a new algorithm in a new object detection algorithm into the into KubeEdge Janus. And then finally for I think we do not see too much new things in story manager, but we are adding more metrics, right? For the benchmarking process. As for metrics is basically still belong to the test environment. So basically we have two kind of things that can contribute to the test environment. First is the data set, a brand new data set, then some actual metrics for benchmarking. And then if we are benchmarking object detection, then I think that the final metric would be something like F1 score or recall or precision, something like that. But if we are benchmarking the end-to-end process, then the metric would be, for example, the success rate of the operation, right? Or I don't know, some other metric like that. So it is important for us to know what is on Earth benchmarking in this project. So I think you need to make a choice. If we are benchmarking object detection, then we need to provide some baselines like YOLO VA, CNN, something like that. But we are comparing the performance of different object detection algorithms. If we are benchmarking the end-to-end process, then we need to provide different algorithms for the whole end-to-end process, and then we see whether we may need to introduce more metrics, because this one is this end-to-end task. The assembly task is a new task for the community, so we may need some new end-to-end metrics. So I think we need to make it clear to what we are really benchmarking in this project. Do you have any idea in your mind, Ronak? we are benchmarking the objective detection itself, or we are benchmarking the whole multi-stage assembly process?
Yeah, actually, my idea was to have the whole end-to-end architecture, like the complete process, not just the YOLO part.
Great, great. Then I think at that point we would introduce more matchings for the whole assembly process. Okay, so maybe you can provide a implementation architecture showing, okay, first we are introducing a brand new data set. Second, we are introducing some end-to-end metrics for test environment. And for test case, we are introduce some multi-stage assembly process algorithm. I think that is 3 parts we are going to introduce into KubeEdge SIG AI.
But actually, when I'll be cutting off those parts, like as you said, the data set should be finally, like for now, focusing on the object detection and in the single tasking work. That is priority right now. And then after we get time, we'll be working on the rest of the features. So for now, if I just stuck on YOLO and the object detection part, then I have to go with just the YOLO matrices, or should I be adding matrices that is end to end? Because after we have time, let's say we have time and we are adding more features, then maybe the architecture is again going to be changed.
But we need to differentiate 2 terms as well. That is the multitask and the multi-stage. To my opinion, this project is in fact a multi-stage single task program. So we are working on some multi-stage assembly process, but in fact it is a single task one. So for example, we are assembling some PCB component, a certain PCB component. For example, a cable. We are assembling a cable. So that is for one task. When we talking about multitask assembling problem, it means that we need to, for example, assembling different components at the same time. And we need some detections and assembly algorithms that can tackle different parts of component in the whole PCB board. So for my opinion, I don't think that is a real practical process in real world projects. In real world projects, in fact we have one machine arm for one task. I don't see the very need of a multitask algorithm can do for a single robot arm. So because I can only conduct one task at one time, so why do we need a multitask one? So I think so that is my opinion mentioned previously. So I believe it's still a single task one, but it is a multi-stage one. That means that we still have different stage for the whole process. First, we need to detect for example, the cable, right? And then I catch the cable and try to assemble it to the PCB board. We need some assembly algorithm. So we have several stages that we need to conduct, but this stage do not need to be conducted at the same time. This stage goes one after another. So so we don't say that it is a multitask one. It is a multi-stage one. So do you see the difference? I think it should be clear now.
Yes, I completely understand.
Okay, great. So it is entirely different for the multitask one and the multi-stage one. And what we are talking about here, our project is a multi-stage one, but it is still a single task. And then that it is a multi-stage one, and then we are talking about how we benchmarking the multi-stage process. Then we discuss the problem that whether we are benchmarking the whole process or we are benchmarking the YOLO process. For my point of view, I think that the very first priority, okay, you should stick to a single task one. That it could have multiple stage, it's fine, but it needs to be a single task one. For example, we are assembling a cable instead of other components. Then we stick to the for example the cable detection algorithm and the cable assembly algorithm in that case. So so maybe for that we first we develop an algorithm for the object detection algorithm for example to find a cable, and then we develop the assembly algorithm for the cable. But after all, we are benchmarking the whole end-to-end process. So our metrics still need to be ready for the end-to-end overall process instead of the YOLO one. That is the difference. So, but it's still up to you, Ronak. You need to let the community convinced about what our choice will be. We are on Earth benchmarking the YOLO one, the detection one, or we are benchmarking the whole process. If we are to benchmarking the whole process, then we need the end-to-end metrics. So our conclusions still consistent, right? We want to benchmarking the whole process. Just but this project need to have some, for example, milestone, and we have our roadmap. We do things step by step. First, we need the detection part, but we do not have too much magic here. We just it is one of the modules needed in our whole project, but we don't design different. We may not need all matches for different modules. We just build the object detection module, and then we add another module of the assembly algorithm. And then after all these modules ready, we have an end-to-end metric design in the test environment. So that is my what is in my mind for the whole process will go. But the most important one, I think, it still should be the dataset itself. We need to have a market model dataset. That is, we not only need an image dataset, we still need some dataset for example, for touch data, right? once we have the multi-model data, we can have the multi-stage process goals. In the first stage, the object detection part, we may only need the image data, but for the assembly algorithm part, we need other sensor data, for example, the touch data. So that connects everything. So first we need to make the whole algorithm as simple as possible, so that we can focus on the dataset preparation. And then as for the algorithm part, it contains two modules. The object detection one and the assembly algorithm one. Finally, we have the end-to-end metric to evaluate all the assembly algorithm process, the end-to-end process. So I think that is the three goals that we are going to contribute to the community. I don't know. Correct me if I'm wrong. I don't think. I don't know whether there is any questions from other considerations for LONAC.
Sir, I understood the whole thing. Just like you mentioned those three goals. Can you just repeat those three goals once again?
Yes. The first goal, we are building a brand new data set. It is a multi-model data set. That means that it contains both, for example, the image data and also for example, the touch data. Overall, it have data from multiple sensors. Now, this is the first goal. We preparing data using multiple sensors. Second one, we are building the algorithm modules. There could be two modules, the object detection one and the assembly algorithm one. And we have had the two modules connecting with each other one after another. For example, we in the single task learning, we first run a object detection algorithm, and then when we find the object, we conduct the assembly algorithm, so that the targeted object is assembled to the position we want it to be. Then that is our second goal. We are building the algorithm modules, but this part should be as simple as possible. We just need to we just want to show that our algorithm is our data set it is usable. It is good for practical usage. So you can take the algorithm as a subproduct of our data set. That is the second goal of our whole project. We make some simple algorithms to ensure that our data set can be used. The final goal of our project, we will be to build some end-to-end metrics to run the overall benchmarking process. So in the data set, we have the training data and the testing data, right? But to justify what algorithm it would be would be fine or would be best for our algorithm, our whole project, we need to benchmarking it. That means that we have some data sets to evaluate what algorithm is the best. Then in the benchmarking process, the last critical part will be the metrics. after our discussion, we aim to end-to-end metric. So we may need an end-to-end metric instead of only object detection metric. That could be some successful rate of the final assembly process, some metric like that. I don't know. So that is our final goal. The third goal. The third goal is to build a end-to-end metric. We don't need too much metrics. Maybe one is already enough, but it needs to be end-to-end. Okay. So I think that is the three goals of our the whole project as far as I'm concerned in after our discussion. I don't know whether I make it clear.
No, I got everything. I'm like everything is clear. I will be making, I will be saying two statements. Just let me know if I'm wrong or not. First thing, I'll be simplifying my data set, postponing the part of the cable assembly and the putting the cable and the if else part where the CNN part where the motherboard is properly assembled or not, that is checked. I'm postponing that part for now for simplifying my data set. And for the complete end-to-end matrices, I'm just introducing one matrix, that is accuracy.
Yes, and of course we want to let the whole benchmarking work. So we need our whole benchmarking executable. So we still need some algorithm modules. Right? We also put some simple algorithms on that to ensure that the data set is usable.
Okay.
Okay. So I think the overall proposal is pretty good for me. We just discuss some directions that how this overall program could go. So I think the currently looks fine for me, and we just simplify it a little bit and make the direction more clear, clear. Yeah. So I don't think I have more comment. I don't know. Are there any questions or comments from our community members?
Hello. I don't have any comments. Well, the proposal looks fine to me. That's all.
Great. Okay, then maybe we can thank Ronak for the excellent presentation, and I'm looking forward to the final proposal.
Yeah, make the update soon, and I will push the commits in the GitHub.
Great.
Okay, that's the end of the international section. So now we will move on to the Chinese section. And in Chinese section, we use the Chinese Mandarin to discuss the proposals. 好的，那接下来的话，我们就进入这个我们的中文的议程，然后今天的话也是先请各位同学就是先分别介绍一下自己的最近研究的一个进展情况，然后先那个我看陈国亮也上来了，那个国亮你那边先开始说吧。喂， 那要不先狗大可能现在暂时不在，要不那个燕豪你在吗？燕豪，要不你那边先说，简单介绍一下。
我这边 PR 已经提交了，然后这周代码已经基本上完成了，就还有一些部分需要优化，目前正在优化。
好的。嗯，然后那个，李文清同学在吗？李文清可能现在也不在。那个，张汉元同学在吗？
老师我在的。
好
呃，
的。
我这边是上周因为开会之前就是把 PR 已经写完了，但是想最
啊，
后再看一下，然后就没有提交。然后这周是把2个核心算法做了一个开发，然后数据集我也
嗯
进行了一个构建。对。
嗯，好的。那个，黄奇玉同学在吗？
在的，就是我现在代码和 Janus 的那个框架进行整合，然后呢，指标也设计了，就是在 Janus 上面能跑通嘛。
好的。那接下来的话，我们就各个议题就继续开始展开来详细讲一下吧。然后那先从那个燕豪你那边开始吧。
嗯，好的，我共享一下屏幕。你好，能看到吗？
可以看到。
嗯，好，然后目前的话，我的那个 PR 已经提交了，就是按照上周说的，呃，就具体一下那个要使用的模型是那个千问2.5和那个千问三，就是最新推出的那个千问三。然后，主要说一下我那个代码已经可以运行，然后跑通一个例子了，然后它这个输出是。稍等，我找一下。它输出的这个评测报告就是类似这样一个 JSON 文件，然后根据各种指标，然后让大模型给它进行一个打分，然后就是整体的流程已经可以跑通了，然后就有一个问题就是它那个智能体生成的海报现在生成的非常简陋，然后就也很不美观。然后这部分代码的话，我大概下周就重新给它优化一下，觉得就可能我看它那个生成的方法可能有点问题，然后可能没有正确的引导那个智能体进行一个输出吧，然后还有一个问题就是到时候我的那个数据集整理出来的话是也放在那个 cargo 上吗？或者是跟着那个上一个那个 government 后面放，还是说我自己就自己单独开一个那个 cargo 链接放进去？然后就这周的工作进展大概就是这样。
嗯，那个数据集应该可以，木老师那边给你建一个新的一个这个 government 的一个数据集，然后到时候你那边再把数据再就是提交到那个 cargo 上。
嗯嗯，好的好的。
嗯，那就是我记得之前我们好像讨论过有一个就是说那个就是它那个输入文件开始不支持什么那个 PDF 格式啊啥的那个问题，应该是解决了。
哦，对，那个是我就是自己写了一个那个数据解析的那个代码，然后后续会合并到那个 Sedona 那个轮子里面。
嗯，就你那块儿你那个是改在哪里？就是说改在那个是那个 Yanos 的那个 Selena 包的里面，然后你增加了一个解析 PDF 的模块。
对，我目前是这样想的，但是我还没有写进去，就是先简单调用一下。我想的就是在那个亚纽斯的塞纳包里，就是加一块儿这个 PDF 这些。
嗯嗯，那好，就是现在的话，现在整个跑通的话，它能有一个结果吗？就是说哪怕比较丑，或者说就是不太好看那
哦，
种。
这个是那个评测的一个输出，就是它各种打分的这个一个输出。然后它那个海报的输出的话，我找一下啊，它海报输出是这样，就非常的丑陋。然后这个代码感觉要重新写一下，它有大问
那
题。
这个图像是生成是你调 API 生成的吗？还是它
对，
那
是
个
就是
啊，
嗯，
就它其实是直接就是你调了 API，它自动就给你生成一个图像返回回来，
对对对。
是吗？嗯，这个我感觉就是感觉是你可以调一下 prompt 或者啥的，就是说最比较简单的话就是它有的生成让它比如说怎么着更丰富一些，或者添加一些什么信息之类的。
对，感觉就是那个 prompt 好像没写明白，应该是这样，我觉得。
嗯，然后它会有一个打分的一个输出是吧？
对对，
打分的输出是啥样的？我再看一下。
就是刚刚那个
对对，
我找一下，
我知道刚刚那个，那
是这样的，
整体的一个打分，这个也是用大模型去打分的。
嗯，对，这个模
嗯，
型用的也是那个千问的那个 VLM。
哦，OK，现在那个，哎呀，PR 还没有合进去是吧？就是那个 proposal 的 PR，
对对，
有 PR，嗯嗯，那我觉得现在整体看还可以，就是说整个流程都跑通了，然后内容上，呃，检测，就是你和孟卓那边他有聊过吗？就是说现在的这个进展情况。
哦，这周还没和孟卓老师汇报一下，就因为就具体的想法上没有太多变化嘛，就是完成代码这一周。
嗯，OK，嗯，行啊，那我觉得
嗯，
还可以，看上去现在，
然
嗯，
后我们尽快把 proposal 合了吧。如果大家没有
对，
其他的疑问的话，然后当我看到那个文件夹结构那里，可能稍微微调一下吧，可以开一下那个，嗯，
是
对，
这种。
就 proposal 里面那个，
应该在 Docs 下面，Docs
哦
example，就是我不知道是不是这个 government agent 的 proposal，还是或者说你直接打开你那个 GitHub 上那个，对，
好，
对我看到好像有2个 PR 是吧？就一个是之前那个有点损坏的那个 PR，
有一个是之前
另外
那个多一个子目录没提交好，然后后面是我重新提交的一个，那个应该是
对对对，你到时候可以把那个
对你把
坏掉那个 PR 给关了，就不然，因为大家会，我刚才就开错了，然后还有点懵，
哦
对，就把它旧的干了，然后呢，呃呃，或者我来共享一下，我
好的好的，
先看起来，对，就这个是那个文件的结构对吧？然后呢， 就 example，然后放在 government agent 这里，我倒是觉得还好。不过最好是到时候这个东西跟我们的数据集的名字差不多。
嗯，对，
我们到时候叫什么比较好？我不知道那个有没有什么想法，就叫 government agent 吗？有没有更精确一些的名字？
嗯，这个目前我还没想到，等会儿再想一个比较具体一点的名字。
对，
可以
假设
问一下
还是这个。
大模型，让大模型帮你想个名字。
对
好的，
对，就一般还是尽可能的，就是把这个数据集本身的特色能够，你看这个一看那个名字就大概知道你是个什么数据集。
嗯嗯，好的好的，
对，哪怕它如果有点长，你后面也可以用缩写嘛。对。然后第二是那个这个 learning bench 是这样，就是我理解它并没有新建一个范式，它其实还是在 single task learning 下面的，对吧？
哦，对对，
对，所以你这里应该是 single task learning bench，不是那个不是这个 agent bench。
哦，这点是我那个之前修改的时候有点疏忽，就不小心写错了，应该。
OK OK。
我等
然后
会儿修改。
好的，那这里是不是就也不需要再加一层文件夹了？是不是就这两个文件夹，然后就直接底下这些文件是不是就可以了
对，应该就可以直接就列下去了。
？OK，好好，行啊。然后其他的看一下图，反正我们可能会有先问三数据指标是否达成的名，还有 test report，然后这个或者是这样子。其他的我觉得 OK 了，反正等你改完这个文件夹结构，我觉得也可以合了。
嗯嗯，好的好的，谢谢老师。
我这边没有了。
OK，我这边也没有，我觉得也是那个验好了就尽快改完之后，然后在群里再说一下，然后我们到时候就尽快把 proposal PR 合录。
嗯，好的好的，谢谢老师。
嗯，好的，那下面那个张翰元同学那边要不来继续来讲？喂，汉元在吗？那汉元可能暂时不在啊。那个黄奇玉同学在吗？
在的，在的，老师能听到
啊
吗？
能听到，要不就你先来汇报。
好的，等一下，我共享的屏幕。老师能看到屏幕吗？
可以看到。
好的。然后今天因为那个我的电脑拿去维修了，然后我现在是用我同学电脑，然后我那个仓库现在还在我自己的电脑上，然后我就用之前截的一些图来汇报一下。然后我现在项目的进度就是因为我那个项目生成那个室内场景，然后我已经把我项目的那个内容合并到 Janus 的框架里了。然后在合并的时候，目前遇到了一个问题，是我之前就截过图的一个问题吧。我看一下这个图里面，就是我现在那个 test environment 这个文件，它就是写了我的train data 和 test data 嘛，它们都是就是相当于是对一个场景的那个自然语言的描述。但是我在把这个东西传给 Janus 的时候，他好像说找不到这个东西，然后这个我当时搞了很久，也不知道为什么。然后这是我在把我项目合并进 Janus 的时候遇到的一个问题。然后呃除了合并之外，然后我还现在也在
好的好的，
呃
我还在开会。
啊
不，
呃除了 除了这个合并进 Yanos 之外，然后我还在实现我的那个，就是实现我的一些指标。然后现在，上次提到的那个叫自然语言的那个一致性，然后我已经找到了一个开源的项目，然后它那个项目是可以去衡量，就是我输入的那个自然语言和我最终输出的那个场景，它们的语义一致性，它可以给出一个呃，就是相当于语义一致性的一个向量，然后可以表示，所以这个指标也完成了。然后其他指标的话，也有很多是在之前论文里也实现过的，然后我现在也在逐步的实现。嗯、然后的话，之前那个 proposal 的话，在上次会议里面提到的那个图片的那个问题我已经改过了，然后现在也请老师再看一下，然后可以合并进去。大概我的项目大概是这样。
你要不再看一下你那个 proposal，就是
这里吗？
对，那个你要不打开一下，就是你那个 proposal 的界面，再 post 到一
嗯，
点。
我看一下这里怎么。
你应该从这个是只能看见那个修改的地方，
嗯
你可以从上面那个就回到你自己那个仓库那块儿，就是上面那个点这个对。
对，这是我目前提交的 proposal。然后之前有问题的地方是，这两张图片，就是上次说的两张图片没有显示出来，然后现在是可以正常显示。
就是你这个文件夹就是叫 simulation 是吗？就是 examples 下面，就是你下面那个文件夹结构。
对，我是先建了一个 simulation，然后再建了一个我自己的这个名字。
你要不再换一个具体一点的，就直接叫 simulation，听起来有点怪怪的。就是说，
哦，那我
大概
就直接，那我要不就直接把 呃，就是把 simulation 改成我自己的项目的名字，然后下面再放一个 single task，这样子可以吗？
呃，不是这样命名的，它那个命
啊，
名是那个根据数据集的名字来命名，不是根
根据
据项目来命名。
根据数据集的名字来命名。
是的，就是目的是为了大家打开那个开源项目的时候，能知道自己在处理或者对于跟哪些任务比较感兴趣，哪些场景比较感兴趣。
嗯
比方说然后可能有不同的那个课题，它会用那个同一个数据集，对吧？但如果
嗯。
按照项目来命名的话，待会我们每年十几20个项目，那3、4年下来，我可能60个文件夹在下面，就不太合
哦
适所以
哦
我们是看那个按场景来。
哦，
现在
那我
咱这个是个生成具身智能的生成数据的一个项目，对吧？
是的。
对，然后可能可能起一个嗯，就可能主要看我们生成的数据是什么数据，我们把它生成一个我记得是生成一个布局，对吧？还有场景的数据。
对，是。
对啊，其实你这里不就有吗？什么 physics scene generate 就
对对对，因为我现
对
在的我现在的那个文件夹结构是，就是 simulation 下面的 single task learning，然后再下面的是那个 physics scene generator，就是那个。
那我建议这样，解释一下，就是这里之所以有这个 simulation，其实是之前就是我们之前有另外一个工作，其实是给那个呃 在 YAML 内部去模拟多个节点，然后它那个 simulation 是那个文件夹放的是那个项目，所以跟咱这个项目是一点关系没有，所以可能不要叫同一个。它那个场景就是为了仿真那个不同边缘节点，所以它就这么它那个场景这样写倒还好。然后呢，我们这个其实是具身智能的，对吧？所以我建议就直接改，你就直接改 basic sense generate 就，反正 example 下面然后就直接这个 basic sense generate 对吧？然后在下面 single task learning bench，然后你就接下来就是剩下就是 test environment 内容。
哦，OK，好的好的。
对，不用打开那么多层文件夹。
哦，OK OK。
好那石金老师您继续啊。
啊，没有，我看那个蒋晨阳蒋博士也上来了，蒋博那边有没有什么 comment？
喂，
喂，可以听到，
可以听到吧？就是我有一个疑惑，就是我上次提到有一个那个3D 场景渲染出来的那个问题，就是目前有没有一个就是我知道就可以生成那个配置文件嘛，就是有没有实际渲染出来那个3D 场景可以可视化看一下？
目前还没有，因为我这个电脑是我朋友的，然后我现在在我自己本地在配置，但是目前还是遇到一些问题吧，我现在正在解决，然后下次肯定可以实现这个，就是渲染。
OK， 行，其他我没有什么问题。
然后我看到之前的那个 proposal，就我们这样子提了几个问题，一个是那个文件夹结构要调整，对吧？这是一个。第二是那个指标的描述，咱有没有那个？
对指标的描述，我这里也重新描述过了，就是包括我们自己提出来的，还有论文里面的一些描述，我都写在这里。
补充好嘞。
对，补充。
第3个是已经改了，然后第4个，就我们对我们选择算法的一个简单描述，比方说我这里生成用的是什么算法。
这个也在这里也详细重新描述了，因为之前描述的时候，比如说像这个它表示物体的这个向量没有仔细描述嘛，然后还有像之前这个它的那个架构那个图，然后现在也都补充上在这里了。
OK， 好的，那我这边对 proposal 本身，我这边的都 comment 都已经改了，就只剩下最后那个文件夹结构改完之后，我这边就会给 LG 点。
好的，谢谢。
也看看那个蒋博还有那个石金老师2位啊，看有没有更多 comment， 尤其对 proposal。
proposal 我这边没有啥新的 comment，我感觉既然就按子木老师说这些都改完了，我觉得就差不多了，我这边可以给GTM。
然后蒋博呢？
我这边也没有什么问题。
对，
谢谢郑博和胡博的跟进。
那蒋博也可以给LGDM，你是导师啊。
对，好的。
你觉得他写的还可以，是可以给一个支持一下。好嘞，行。那是不是时间交回给主持人？
好的，那我把那个屏幕先结束共享，然后我下会之后，把那个文件夹结构改一下，然后重新提交一份 proposal。
对，我看到你出了那个签名问题 ，ECL error。对，
那个应该是第1版的时候，我好像后来应该都签过了。
那可能 rebase 完再交一下是吧？
对，那个你那个 commit 也要把它就是 rebase 一下，就现在4个 commit 其实不需要，应该就 proposal 就1个 commit 就够了，就是你把它rebase 之后，然后把它可以 scratch 成一个 commit。
好的，那我再回去改一下，谢谢老师。
好的，那下面那个陈国亮同学在吗？
老师在的。
行，那你这边来讲一下吧。
老师可以看到屏幕吗？
可以看到，
因为上周嘛，上周的话，我在上周我也参会了，然后的话就是根据那个子墨老师的建议的话，把这个 proposal 给改了一下，然后现在是已经并入到那个社区里面去了，对。然后的话，这一周的话就基本上在那个对那个数据进行那个打标签，对。然后的话，就是这一部分那个算法。现在是在做这3个文件的配置，对，它大致情形就是这样。
好的，后面反正因为我们投入的时间稍稍晚了一点，然后我们现在剩下最后1个月，对吧？或者之前没有了，现在已经11号了，然后我们还有2周，所以我估计对国亮来说可能最好是这周或者对吧下周初，然后有第一版的那个数据能整理出来，然后呢，接下来大概就还有1周左右的时间把那个算法调通。这样的话，我们下一次，其实最好是下一次的时候，你就可以给我们做一个展示了，就是跑通整个过程。
好
然后
的。
按理我们是期望说能看到跑完，然后有个排行榜出来的，那就是正常的结果。然后如果顺利的跑出来了，你就把那个代码往那个社区提个 PR，就实现的 PR。
就是到的时候的话，如果实现的话，就是往那个社区提一个 PR，就是把这些文件给提交上去。
对的，所以
好的。
或者我们可以考虑倒过来，你可以考虑先赶紧跑通，然后呢，先哪怕那 YOLO 效果贼差，对吧？那个抓物体都抓不起来，什么或识别不到也无所谓了，就先跑一个出来，关键能跑通，然后能看到那些指标，对吧？然后你再慢慢的那个加税级，对吧？然后看那个 YOLO 效果能不能上来。
好的，我抓紧。
好，那就期待就是按理那我们就恢复到2周一次，对吧？就是到时候你就按正常时间上来，按理下一次可能是25号，然后
对。
对，然后那时候最好是有个 demo 给我们看一下，然后最好是 PR 了也已经交了。
好的。
好嘞。
就是我们这个最终的那个呈现形式的话是要有那个排行榜吗？
对，其实本来也有，对吧？我们那鸭子跑完本来就会打个表格出来的。
对。
只是说你那个表格可能指标稍微改一下，对吧？就是变成那个目标检测的那些什么 AB score 啊、precision 啊，
好的。
对。现在我这边没有了，我觉得应该还是接下来其实重点，我估计跑通不会特别特别难，所以我觉得你可以先试着把那个给搞通了，这至少我们合作其实就没有太大问题，然后就把精力投到那个税基的整体的完善上。
好的，我下去慢慢改代码。
好，加油加油！
加油加油！
好，我这边没有其他了。那是不是时间也交回给主持人？哦，那个石金老师那个有事情，先下了。然后我们刚刚是不是还有一些其他的议题？
那老师，我这边先退出共享了。
好，没问题，辛苦啊。
好。
然后我刚刚文清是不是不在？喂，现在文清在线上吗？ 文心在吗？如果不在的话，有没有其他的那个成员想 share 工作的？上次汉元
嗯，对，老师，
忘记，
老师我在。
对对，上次汉元是不是没有来？我忘记了。
上次因为有事儿，我提前离开了，没有上会。
哦，要不现在给他过一下。
嗯，好的好的。刚好今天就是过来过一下。就是这个是我现在最后改出来的那个 proposal，然后就因为还是中英文两个版本的，我就按照中文版来讲吧。
对呀。
就是应该最后的那个 proposal 的那个名字应该是英文版的这个，就是根据这个 PIPL，然后就是中国的个保法做的一个隐私框架。呃然后呢，就是摘要部分之前应该都看过，然后现在就是我最后考虑了一下，应该是鞭策模型是用拉玛三的8B，然
哎，我
后
我问一下，那个咱现在这个 PR 的 proposal 交上来了吗？
我是本来准备上周来交的，但是因为上周没有上会，然后我就没有交，准备今天过完我就交了。
其实你应该先交完，然后我们好在上面看嘛。
好的。
尽快好不好？就
今天会完我就交上来，因为上周没有
那这样的话，
开会。
我们容错可能会很糟糕，就是可能你最好是一把能过。那
OK
个
OK，那个然后
比方说你什么签名啊，什么那些东西，就记得啊，就不要漏了。
好的。
然后
然后
commit 要
云编的。
对，然后我们
嗯，
看一下，哎，因为我们就时间关系，我们就不从头过到尾了。然后呢，
好的。
你还记得我们上次其实这有个问题，反正你还记得我们上次提了哪些问题吗？
上次就是一个就是两个模型的问题，就是我现在是一个是鞭策模型是 Llama 3，然后云编的话是会用一个 GPT 的4O 去做一个接口吧。然后是数据集，现在我最后构建数据集是从一个就这个数据集里面找2000条训练，500条验证，还有500条测试，这样做一个轻量的数据集。然后上次还有一个就是说到那个，就是让我把那个整个场景做一个示例的细化，这个部分就是场景示例的细化部分。
嗯，我也有点忘了，就是不是我们在上面做脱敏是吧？
对，就对它的一些关键问题做脱敏。对。然后下面是就是上次，因为上次问题其实还比较多，然后这个是上次没有补上去的那个架构文件夹。
它需要在 example 下面，然后我们建一个，就是我们那时候那数据集叫什么名字来着？
呃，当时是用了亚马逊的数据集，后来我是在里面抽取了一部分做数据集。
那个数据集名字叫啥？有没有
呃
有没有一个名字，或者哪怕是你
就是
起的也行。
行，那我就抽取以后我自己再起个名字。
OK，那这样就到时候就是 example 下面，然后你就建一个文件夹名字，然后文件夹名字就是 dataset 本身的名字，
OK。
然后接下来就是什么什么 bench，嗯，
嗯。
然后你现在用的是我有点忘了，你是用的云边协同推理还是 single pass
呃
learning 来着？
云面协同推理是 Yanos 那个云面协同推理。
哦，那这样，所以你第一层文件夹是那个 YAML 下面的 example，然后 example 下
嗯。
面是反正亚马逊的一个数集，然后接下
对。
来在下面的Edge Cloud Cloud Edge Collaborative Inference 对吧
嗯。
？Bench 这是第3层文件夹，然后第
好的。
四第就没有第4了，然后剩下的东西你就都扔到那个 Cloud Edge Collaborative Inference Bench 那里。
好的。然后
接下来记
下面就
记记记下来了吗？别太忘了啊。
接下来就是有两个，就是我最后重新又画了两个图。
嗯
一个就是整个端到端的那个流程图，大概就是这个样子。 用户之间的这个从云端上传数据，然后做处理，做完处理，然后在云端就是这样一个过程，对，去做一个向量化。
呃嗯，哎，上次应该是聊过，你应该按照那个云边协同的组件来画，对吧？就
嗯，对。
一个是单边和云你画了，但是你没漏画了中间那个 high example mining。
high example name，哦，应该是对。
而且那应该是你的最关键的模块，你其实是在改，你在提出一个新的 high example mining，那它可能是呃也
老老，
我想想啊，
你能再说一下吗？
要
没有太听明白。
我想想，是这样子的，我们的云边协同推理的那个流是这样子的，它有两种流，一种是那个先做鞭策小模型，然后再做一个那个难力上云的一个决策，然后再到云上面去，这是第一种流程。然后第二个流程是说，我上来先做一个决策，就是说我到底是去编还是去云，然后呢，如果选择去编，那他在边上做，对吧？然后去云的话，他就到云上做。就我们现在有这两种结构，然
嗯，
后我们上次应该是讨论过吧，然后
对，
咱这个
应该我是后一种方式，应该是。
就要选编还是云是吗？
对对对，因为
那有个问题，你要打算怎么选？就是什么时候上去编，什么时候去云呢？
就是通过我这个 PIPL 的这个分类，就是根据它这
啊，
个法规的分类器。
行，那你知道这个流程都要改一下，就是要把那个呃前面那个选择的那个模块，你看一下，完你可以看一下代码本身，对吧？就我我有点忘了，按理那个模块好像也叫 high example mining，只是当时翻译的把它顺序改了一下，先走 high example mining，再去编和云，我记得是这样，你可以 make sure 一下，可以
嗯，
确认一下，
好的好的。
对，然
呃，
后重新调整一下这个流程。
好的好的好的。
嗯
那还
呃
有一个就是整体的这个架构图，还是一个基于这个的整个的一个架构，
都同
大致内容差不多。
我们上次应该也聊过对吧？你应该要按照那个就是我们 Janus 的架构图来画，而不是自己
嗯
建一个。然后
嗯，
Janus 的架构图你见过对吧？
对对对。
要不要我再讲一遍？我要不再讲一遍吧？对，估计你可能
好的好的，谢谢老师。
这个差距补给一下。嗯，
嗯，好的。
那你先示范一下。
老师您说。
没事，你先示范一下屏幕，释放。
哦哦，哎哦，你能看到呀？
不是，我是说你要解除你自己的屏幕，你现在看不到我的屏幕，对不对？
哦哦哦
你得先，
哦哦，不好意思啊，不好意思啊。
对对对，嗯，这是我们的架构，然后呢，
嗯
需要你加什么东西呢？就是你画一个类似的图，然后呢就讲清楚了。
嗯
首先在这个 Test Environment Manager 里面，税级你
嗯，
肯定要画一个新的了，对吧？就肯定不是之
对对对。
前我们一个是一个新的税级，然后刚才好像说
嗯
亚马逊的一个什么什么税级，你起个名字，对吧？然后这里
对。
你标个不同的颜色，就说这个东西是我新加的啊，在这个项目里面。然后接下来
嗯
metric，你应该是加了一大堆那个应该是隐私相关的那种检测指标吧，对吧？
对对对。
那你就加在这里，就说我打算给社区加一个这些指标，然
嗯，
后当然你 highlight 一下哪些是你新增的，比方说你标个红色的，然后这里都是蓝色框，你个红色框就是说我这个是以前社区没有的，我这次项目新加的。然后 test
好
case
的好的。
结束了，我们应该还是在云边协同推理那里就把你现在用的是云边协同推理，你至少把它列在这里，但我们可能不做任何修改，
嗯，
然后就结束了，所以就很简单，所以你就是主要是改了那个税级和指标，嗯，然后你可以考虑，
好的好的。
当然你可以考虑在算法那里，然后有个云边协同推理，然后呢 然后呢，稍微你可以在下面是搞个小分支说哦，你加了一个什么算法，对吧？
OK OK，明白。
行啊。
这个好像上次确实没有讲，我才想起来。对，嗯，
OK，然后
然后
我们把架构图也算，就像刚才提了流程图，然后架构图，然后那个税级，然后你最后给我看一下那个那个文件夹结构好像刚才也对了，是吧？
对，文件夹结构刚刚已经对过了，在这儿。
对，到时候就是反正该那几层你都加上去，主要是那几个，然后剩下的其实我们之前也有一些讨论了，今天就先不对了，我们先把
对，因为
那个
两个算法我都找了相关论文，复现了两个算法，已
对
经做了。
我估计应该问题不大，你里面都有
对
算法描述对吧？我刚才好像有
对，
问到
这个都写过了，因为我之前前段时间也找了几篇论文写的时候再看了几个。
好嘞，那就这么着，然后我们就主要是刷一下那个流程图、架构图和那个税级和文件夹结构。
好的，数据评测指标还要看一下吗？
今天就先不看了。你可以跟
行
那个嘉欣老师那边也稍微汇报一下。
好的
主要是看
我今天
他那边的，你主要是看看他那边觉得 O 不 OK。
OK，
好嘞，
我今天赶紧先把 PR 我改完以后交个 PR，我先。
对，尽快交上来，然后我们得赶紧合了，因为马上马上要结项了。
对，因为上周本来想交来着，结果没来得及上会。
对，嗯，我建议你下周再来一次，
下应该后面2周都会按时来的，因为我
对，
上周是就本来每周都想来，然后上周是有事儿，中途就走掉了。
对，那个然后到时候很可能您到时候我觉得很有可能你那 PR 弄完，然后史金老师还没看，对吧？然后你请给他讲一下，然后我们争取下周赶紧把 proposal 合了。如果没有合的话，我们这项目是结不了项，就你肯定要赶紧合。那合完你就赶紧针对这个东西把代码对吧跑通出来，反正我们应该是最后想看到你跑完应该是输出一个表格这样子，然后还有些指标。
明白，就是我代码，
你
其实我这段时间有跑通过，有跑通过已经。
对，那你就跑一跑，然后只是说那个它算法只是说精度问题对吧？没所谓，就我们项目对这块没有说很高要求就。好不好？
好的。
对，然后最好我觉得甚至建议你干脆下一次，一个是你把那个 proposal 赶紧弄上来，对吧？然后呢，第二是你甚至可以考虑找个项目，然后把你现在的那个代码的 PR 都可以考虑再交一个，如果你下次过来展示的时候能跑通的话，你到时候看看。
好的，我下次应该可以。之前算法
嗯
已经跑通过，对。
对，我反正你做 PR 的小心一点就是了，就是有些同学会交那个 proposal PR 的时候不小心把代码也全交上来，就你到时候看一下，是吧？尤其是第一次
好的，我应
PR
该
的同学，
这个上面有一部分代码，但是不是全部。
proposal 是不允许有任何代码的，OK，
OK，
对，你要的话你就描述一下算法的那个就是逻辑，或者说什么原理之类的，你可以写，但是不要在里面弄代码，然后包括那个 PR 本身也不要带那些代码的要 Python 的文件，到时候不要在同一个 PR 里面，就把那个 proposal PR 跟实现 PR 分开，就 proposal PR 里面全是文档，顶多有个把图片，然后实现 PR 里面就一堆代码，就把这两个东西分开，你交的时候自己看一下，好不好？对，然后我们争取下周一次过。
好的。
好嘞，行，那咱先到这，
再见。
好，辛苦，
嗯。
那个文心还在吗？如果没有的话，那要不我们今天的会议就先到这里，然后文心那个看看是不是下周也再下来一趟，一起看看。好，感谢大家的参会，各位拜拜。